I'm Marquenan G. Domingo, a BSc student at Lyceum Northwestern University. In this video, I will show you how Newton's second law of motion is applied in vertical direction and an inclined surface. Here, I will demonstrate the law of acceleration in vertical motion and an acceleration in an inclined surface. I have here a hook, a box, and a ribbon. I will hang this box in a hook using this ribbon. Here, we need to calculate the net force that acts on this body. Let's assume that this box has a mass of 1 kilogram and is initially moving downward with a constant acceleration of 2 meters per second squared. You can see that there are only two forces that acts on it. First, the tension force that supports the ribbon while holding the box being moved downward, and the second is the weight, which is the gravitational force. In the law of acceleration, net force is equal to the mass of the body multiplied to its acceleration. Since it is an acceleration in a vertical direction, its net force will be calculated on the y-axis only. In a constant acceleration, net force will be the sum of forces acting on a body, which in this particular situation, the summation of the tension force and the gravitational force or the weight. Suppose an empty box weighing 2 kg was released from rest at the top of a 5-meter long frictionless ramp. It slides downhill and obtains an acceleration of 2.5 meters per second square as it reaches the bottom. We can witness that in Newton's second law of motion, an applied force that acts on a body will make the body accelerate. And it is always the case that the direction of the acceleration of the body will be the same as the direction of the net force. Now, if an unbalanced force is applied to an object, the object acceleration will depend on its mass. Say for example, I will stop the empty box with a piece of clothing to increase its mass. If the mass increases, a greater force is necessary to accelerate it. In this case, a greater force is needed to be applied to the box compared to the force applied when it is empty to accelerate the object. The relationship between mass, force, and acceleration is fairly straightforward. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force applied and inversely proportional to the mass.